Students, in this question we have to show that the chord of curvature through the pole of the given curve r is equal to a to the power e to the power m theta is 2r. यहाँ पर गिवन कर्व r is equal to a to the power a multiplied by e to the power m theta है, ये गिवन कर्व है और हमको फाइंड करना है chord of curvature through the pole. And we know that formula for the chord of curvature is through the pole is 2 rho sin phi. So first we find here radius of curvature, that is rho. So we differentiate the given curve with respect to theta. Differentiate given curve with respect to theta. So we get here dr by d theta is equal to a d by d theta of e to the power m theta. Here a is constant, so it will be outside the differential operator, and differentiation of e to the power m theta with respect to theta, this is m e to the power m theta. And from the given equation of curve we can see here a e to the power m theta is equal to r. So we put here in place of a into e to the power m theta, we place here r. So dr by d theta is equal to r by rm. So this is dr by d theta. आप देख सकते हैं यहाँ गिवन कर रहा है r इक्वल टू ए ई टू पावर एम थीटा, इसको डिफरेंशिएट कर रहे हैं थीटा के रिस्पेक्ट में, तो डिफरेंशियल ऑपरेटर डी बाई डी थीटा यूज करेंगे वो साइड में. सो डी बाई डी थीटा ऑफ r इक्वल टू ए डी बाई डी थीटा ऑफ ई टू पावर एम थीटा. यहाँ पर a कांस्टेंट है, तो इसको डिफरेंशियल ऑपरेटर के बाहर रखेंगे. ई टू पावर एम थीटा का थीटा के रिस्पेक्ट में डिफरेंशिएशन होगा m ई टू पावर एम थीटा. गिवन कर्व की इक्वेशन से आप देख सकते हैं a e to the power m theta is equal to r है, तो इसके प्लेस पे r रखेंगे तो dr by d theta equal to r by m होगी. Now we know that 1 upon p square is equal to 1 upon r square plus 1 upon r to the power 4 dr by d theta whole square. This is the relation we learned about this relation in the chapter tangent normal. So we put here value of dr by d theta, that is 1 upon r square plus 1 upon r to the power 4, and dr by d theta is r square m square. Now from this r square we cancel this power 4 and get here 1 upon r square. So 1 upon r square plus 1 upon r square m square is equal to 1 upon p square. So we taking here LCM. So this is 1 upon r square is LCM, r square is LCM, and here 1 plus m square, and here 1 upon p square. We can see here in the right hand side r square is LCM, so 1 plus m square in the numerator, so 1 upon p square equal to 1 plus m square upon r square. Now reciprocal both sides, we get here p square is equal to r square divided by m square plus 1. So here we can see this m square plus 1 multiplied by p square is equal to r square. We can see this is the equation in terms of r and p, and we know that any equation in terms of r and p is known as pedal equation. So here we can see that this is the polar equation of the given curve, and we convert this equation into polar pedal equation. आप देख सकते हैं यहाँ पर गिवन इक्वेशन पोलर इक्वेशन है, क्योंकि r और थीटा के फॉर्म में है. इसको हमने r और p के फॉर्म में एक्सप्रेस किया, सो दिस इज द pedal equation. Now we find here dr by dp. So this is equal to r square is equal to m square multiplied by p square. Now we differentiate with respect to p, so we get here d by dp of r square is equal to m square plus 1 and d by dp of p square. Here we differentiate this curve with respect to p. P is the length of perpendicular drawn from origin on the tangent. So इसके लिए हम d by dp ऑपरेटर यूज कर रहे हैं. यहाँ पर m स्क्वायर प्लस 1 कांस्टेंट है, so it will be outside the differential operator. Now we differentiate r square with respect to p, so this can be written as d by dr of r square multiplied by dr upon dp. And on the right hand side this can be written as m square plus 1, and differentiation of p square with respect to p, this is 2p. So here differentiation of r square with respect to r, this is 2r dr by dp is equal to 2 times m square plus 1 p. So 2 from the left and right both cancel. So this is r dr upon dp is equal to m square plus p multiplied by p. आप देख सकते हैं यहाँ गिवन कर्व की इक्वेशन पीडल फॉर्म में है, आर स्क्वायर इक्वल टू एम स्क्वायर प्लस 1 पी स्क्वायर। इसको हम डिफरेंशिएट करना है पी के रिस्पेक्ट में, इसलिए ऑपरेटर लगाएंगे बोथ साइड में डी बाई डी पी। सो डी बाई डी पी ऑफ आर स्क्वायर इक्वल टू एम स्क्वायर प्लस 1 डी बाई डी पी ऑफ पी स्क्वायर। हियर एम स्क्वायर प्लस 1 इज कांस्टेंट, सो इट विल बी आउटसाइड द डिफरेंशियल ऑपरेटर। यहाँ पर एम स्क्वायर प्लस 1 कांस्टेंट है, तो डिफरेंशियल ऑपरेटर के बाहर लिखेंगे। पी स्क्वायर का पी के रिस्पेक्ट में डिफरेंशिएशन होगा 2p एंड आर स्क्वायर का पी के रिस्पेक्ट डिफरेंशिएशन निकालने के लिए इसको लिखेंगे डी बाई डी आर ऑफ आर स्क्वायर मल्टीप्लाइड बाई डी आर बाई डी पी। नाउ डिफरेंशिएशन ऑफ आर स्क्वायर विद रिस्पेक्ट टू आर इज 2r multiplied by dr upon dp is equal to 2 times m square plus 1 into p. Now 2 from both the sides cancel out, so r dr by dp is equal to m square plus 1 into p. And we know that for finding the radius of curvature of pedal equation, formula is rho is equal to r dr upon dp. This is the formula for finding radius of curvature for pedal equation. So r dr by dp is equal to m square plus 1p. So radius of curvature is m square plus 1 multiplied by p here. So this is the radius of curvature of the given curve, that is rho is equal to m square plus 1 multiplied by p. Now we know that chord of curvature through the pole is chord of curvature through the pole is 2 rho sin phi. So we put here value of rho and phi and we get chord of curvature through the pole. So we know that since tan phi is equal to r d theta upon dr, we know that tan phi is equal to r d theta by dr, and from here we can see dr by d theta is equal to rm. So d theta upon dr is equal to 1 upon rm. So we put here value of d theta by dr. So this is 1 upon rm. So this r cancel by this r. So we get here 1 by m. Now we know that if we take this is the right angle triangle and suppose that this is phi. So tan phi is equal to perpendicular upon base. So this is 1 and this is m. Now we find here this hypotenuse. So hypotenuse square is equal to perpendicular square plus base square. Here perpendicular is 1 and base is m. So 1 square plus m square is equal to h square. So h is equal to under root 1 plus m square. So we get here sin phi is equal to perpendicular upon hypotenuse, that is perpendicular is here 1 and hypotenuse is root of m square plus 1. So put here value of sin phi and rho and get the chord of curvature through the pole. So chord of curvature through the pole is equal to 2 rho sin phi. Now we put here value of rho, that is m square plus 1 multiplied by p, and sin phi this is 1 upon under root m square plus 1. We can see here this m under root m square plus 1 cancelled by this. So we get here 2 root of m square plus 1 p. And from the given equation 2 we can see here r is equal to under root m square plus 1 into p. So from equation second r is equal to m square plus 1 under root multiplied by p. So we put here in place of under root m square plus 1 into p is equal to r. So chord of curvature curvature through the pole is equal to 2r. आप देख सकते हैं यहाँ पर जो chord of curvature through the pole है उसकी इक्वेशन, उसका फार्मूला है 2 rho sin phi. So first we find out here rho, that is the radius of curvature, is m square plus 1 multiplied by p, and here we find out sin phi. So we know that here tan phi is equal to r d theta by dr. So we put here value of d theta by dr. Since we know that dr by d theta is equal to r by m, so d theta by dr is 1 upon r m. So put here d theta by dr, that is 1 upon rm. So r from the numerator and denominator cancel out, so we get 1 upon m is equal to tan phi. Now we draw a right angle triangle. In this triangle we suppose that this is the angle phi, and here we know that tan phi is equal to perpendicular upon base. So perpendicular is 1 and base is m. So we find here hypotenuse. So that is hypotenuse square is equal to perpendicular square plus base square. So perpendicular is 1, so 1 square is 1 plus base is m, so m square. So hypotenuse is square root of 1 plus m square. Now we know that sin phi is equal to perpendicular upon hypotenuse. So perpendicular is 1 here and hypotenuse is under root m square plus 1. Now we find chord of curvature through the pole, that is 2 rho sin phi. So we put here value of phi, that is m square plus 1 multiplied by p, and sin phi is 1 upon under root m square plus 1. आप देख सकते हैं ये अंडर रूट एम स्क्वायर प्लस 1 जब कैंसिल करेंगे तो इस पे रूट लग जाएगा, तो रूट एम स्क्वायर प्लस 1 इन मल्टीप्लाइड बाई पी, एंड फ्रॉम गिवन इक्वेशन सेकेंड वी कैन राइट आर इज इक्वल टू रूट ऑफ एम स्क्वायर प्लस 1 मल्टीप्लाइड बाई पी. सो वी पुट हेयर अंडर रूट एम स्क्वायर प्लस 1 इंटू पी इज इक्वल टू आर. So we get chord of curvature through the pole is 2r. Thank you.